Hello student, welcome you in my YouTube channel. Today we are going to see the unit number 1 from pharmaceutical organic chemistry 2, that is called as a benzene and its derivative. So my dear friends, so in 1827 Michael Faraday isolated the benzene, and that was the first incident that someone isolated the benzene. And then later on in 1865 the Auguste Kekule proposed the structure of the benzene, that how the benzene is. And today we are going to utilize the benzene in many synthetic procedures and as a solvent in many reactions. So first of all, before going to start to this unit, let us focus upon the syllabus of Savitribai Phule Pune University. So this will be most helpful to the student who is directly admitted to the second year B Pharm. So this is the syllabus of SY B Pharm and semester 3 in pharmaceutical organic chemistry 2, and these are the objective that at the end of this syllabus the student must aware or must have a knowledge about this, write the structure, name and the type of isomerism of organic compound. Then a student should able to write the reaction, name the reaction and orientation of reactions, then account the reactivity, stability of the compound, and this is about the practical. This is the practical, that in practical you have to prepare a small compounds. So in this syllabus, this objective, so you must be aware that in your examination the question will be asked on these three parameters, that is the structure, name, isomerism, then orientation, reaction, and like this the structure will be, the questions will be asked on these points only. So there will be the explain, elaborate, discuss, account, or write a note on. The question will be like this, but it should be around these points only. Okay, so to cover these points, to fulfill this object, we have the content of our syllabus, and this syllabus is categorized into the unit number 1 to the unit number 6. So here unit number 1, that it carries 10 hours, and I think already diploma students are get late for the admission in direct second year B Pharm. So you have to consider the value of the time. So benzene and its derivative, in the benzene and its derivative, so benzene, its orbital picture, an important, that is a Huckel's rule, and the reactions of benzene is asked. Then effect of substituents on the reactivity and monosubstituted benzene compounds towards the electrophilic substitution reaction. So we will going to focus in detail in this video on unit number 1. So apart from this, unit number 2, that is a very simple chapter, that is a phenol, and in unit number 2 this is a phenol and aromatic amine. So you have to discuss with this aromatic amine and phenol in detail in this unit. So in unit number 3, it is for 10 hours, and it is very interesting, that is a stereo isomerism. So I have prepared many videos on this topic, so you may find these videos on my YouTube channel, that is a KP Pharma Corner. Then out of this stereoisomerism, so you have to focus only on optical isomerism and geometrical isomerism, because these are very important from the point of view of drug and drug design. Then unit number 4, so some polynuclear hydrocarbons are mentioned, and in that polyhydrocarbons, so you have to discuss about the anthracene, diphenyl methyl, triphenyl methane, naphthalene and phenanthrene rings and their uses. So only important thing is you have to go through their synthesis procedure. So any two synthesis procedure you have to go. Then reaction. So after having understanding of unit number 1, that is benzene and its aromaticity, so you can easily write the reaction of these polynuclear hydrocarbons. Then there are medicinal uses. So what are the uses of these polynuclear hydrocarbons, that you have to go into the detail. So very 3-4 uses you can remember for every polynuclear compound, and that will be enough for the unit number 4. Then unit number 5, that unit number 5, it consists of theories of cycloalkane. So how the cycloalkanes are formed, what is the geometry of cycloalkane and their stability, and this is all because of the one important parameter, that is called as a strain, and how this strain is created. This all knowledge you will get into the unit number 5. So unit number 6, actually it is a very short unit of 2 hours, and in that only fats and oil. So you may come across to this unit number 5 in 11th or 12th examination, or in biochemistry it might be there. That is a hydrolysis of fat and oils, saponification and rancidity of oil. So this chapter it just asks for 2-3 marks, or write a note on saponification. And in practicals, there is a practical on to determine the saponification value of a given oil sample. And this hydrogenation and hydrolysis reaction, this will be asked for 2 marks, and this question, and this unit number 6 never ask for any kind of compulsory question that carries 10 marks. So you should be aware and don't get fear about that POC-II contain total 6 unit. Actually this unit number 6 is a very short, so you can consider it as one unit. So only you have to consider unit number 5, unit number 4, and very important is unit number 3, because most of the question that are asked in the compulsory section, that is of stereoisomer, polynuclear hydrocarbon and cycloalkane. So dear student, let us focus upon the benzene and its derivative. So while looking inside this unit, so we are going to mainly focus on the benzene, the reactions of benzene and the reactions of Friedel-Crafts alkylation and acylation, and before that we have to go nitration, sulfonation and halogenation, and these reactions are already covered in your 11th in your 11th standard, but here you have to go through the mechanism, and very interestingly you have to see the effect of substitution, that how the product is get oriented, and this is because it is mentioned in your objective also, because this objective mention that student should able to understand the orientation of the reaction, as well as you should able to write the reaction having benzene having a substitution. So dear student, let us join to the unit number 1, that is benzene, Huckel's rule and the various reaction of benzene. So dear student, as I told you that this benzene is a 6-member carbon compound, consists of alternating double bond and single bond. Nowadays we have a lot of information and utilization of benzene in our synthetic chemistry and in paint industry also. But you should aware that this benzene was firstly isolated in 1827 by a Michael Faraday as an oily substance. He noticed that there is an oily substance and there is a biphase when it is added to the water, and later on the research is going on, and in 1865 there was a scientist called as a Kekule. The name is August Kekule. In 1865 he proposed the structure of benzene and he tried to explain the various aspects of the benzene, and finally whatever structure we have is this benzene. But before that, student, this benzene consists of 6 carbon and 6 hydrogen. That this 6 carbon, they join together by a single bond and by double bond, and these are single and these are double bond. These are this single and this double bond, we know that the bond length of a double bond and a single bond is get vary. That is a carbon carbon single bond, here bond length is a 5.56 is the bond length, and whereas carbon carbon double bond, it is encounter as a near about 3.6. But this was the scene that the Kekule explain or propose, that the benzene contain alternative double bond and single bond, and he proposed a two isostructures of a benzene containing alternating carbon carbon double bond and single bond. So here, so what the Kekule propose is that, so there are a two kind of structure might be present. So in that one structure, the alternative double bond and single bond that may present like this. It means that there is a single bond, and in another structure there is a double bond. So this is a first structure and this one is a another structure. So these two structure were proposed by Kekule and try to explain the hidden aspects of benzene. But later on there was a scientist called as Diva in 1964. Finally he explained the structure again about the benzene and their aspect, and whatever information today we have about the structure of a benzene is that, first, that a benzene is a flat structure. So benzene is a flat structure. It means that this structure will be like this. And again, this benzene consists of sp2 hybridized carbon atom. So all 6 carbon in a benzene are sp2 hybridized. So as I explained you, this benzene contain alternating single bond and double bond, and there is a difference in the bond length of a double bond and single bond, and it was calculated as an average and was noticed as a bond length, that is a 1.40 Armstrong. So it is neither carbon carbon double bond length or neither a bond length of a carbon carbon single bond. So as I explained, this benzene is a sp2 hybridized carbon atom. That means that all 6 carbon, these all 6 carbon are sp2 hybridized. It means that there is a question about their geometry, and my dear student, these all 6 hydrogen, they angle together with the benzene of a 120 degree. So what is the requirement of a sp2 hybridization? So the structure will get a flat geometry. Again, this structure will have a bond tetrahedral angle, you can say that, of 120 degrees. So this benzene has a exactly 120 degree angle. So this is all about the structure of a benzene. And benzene, one more thing you must understand, that is fourth one, that is benzene is a aromatic. So in next we will see how the benzene is aromatic, what are the requirements for the aromaticity. But before that, this is all about the structure of our simple benzene. And dear student, you will enjoy this benzene structure in upcoming medicinal chemistry or any pharmaceutical product. There is always presence of a benzene, and that's why the more emphasis is given on the understanding of the benzene, not only the structure but also their reaction, their orientation of the product, because this benzene gives a variety range of the derivative that the student must know. So this is all about the structure of the benzene, and let us focus upon the hybridization or the orbital picture of the benzene. So dear student, this benzene is a flat, and if you see from the side to this benzene, so this benzene look like this. So it is a flat one, and there are these pi orbital, these are present over here. So this is all about the orbital picture, and here these p orbitals are overlapping over here. This may overlapping to this p orbital, and this may get overlap to this orbital. So this overlapping may be present over the structure or below the structure, that is above the plane or below the plane. So this overlapping is nothing but a cloud of pi electron. So this is what, so in this p orbital there is a pi electron. So these are pi electrons, they get, they form a bond, and also they get delocalized. So delocalization and relocalization is a continuously going on process in the benzene. It means that from one, so these two orbital get interacted, and later on again these two pi electrons, they may get interacted, and that's why the bond length of these all this carbon carbon bond is equal. And dear student, due to this pi circulation, because this is a continuously circulating delocalizing and relocalization, because of this we can propose one structure of benzene, that in that benzene there is a pi circulation present over the plane, but we cannot say that this pi circulation is only above the plane, but that might be present below the plane, and that's why the geometry or the orbital picture may be look like this. So this is all about the pi electron and their orbital picture, and this is all about their circulation, and therefore one can write the structure of benzene like this also. So the structure of benzene can be written like this, because these are pi electrons. These pi electrons are continuously circulating. That is called as a delocalizing and relocalization of benzene, of pi electron. So dear student, so this is all about the hybridization or the orbital picture of the benzene, and here you have to focus on the next topic, that is whether this benzene is aromatic or not. So benzene is aromatic, and likewise how to decide the aromaticity of compound. So a compound containing alternating double bond and single bond, the compound must be the flat structure and it must have a planar geometry, and very interestingly this structure must be a cyclic form, and therefore we can apply one rule that is called as a Huckel's rule. This Huckel's rule is used to determine the aromaticity. It is used to determine aromatic and non-aromatic nature of a compound. So whether our compound is aromatic or not aromatic, that we can determine by using this Huckel's rule. So what is the Huckel's rule? This Huckel's rule is a very simple. So it is a 4n plus 2 pi electron. So this is 4n plus 2 is equal to pi electron. So these pi electrons you have to count. And whatever the value of n you have to calculate, and if the value of n is a complete number, that is n is equal to 1 2 3 4, likewise it must be the complete number, and if it is a complete number then our compound will be the aromatic. By looking at the structure we cannot say that our compound is aromatic or not, my dear student. So there are a few criteria before applying the Huckel's rule. In that, first is the compound must be the cyclic structure. So what are that? So it must be the cyclic. Second one, it must containing alternative double bond and single bond, and the structure must have a planar geometry. Once these three criteria they get fulfilled, then you have to apply to the Huckel's rule, and if the Huckel's rule gives you n value of n is equal to 1 to 3, it means that the given compound must be the aromatic in nature. So let us see one example. For example, whether we have to decide our benzene is aromatic or not, whether our benzene is aromatic or not. So let us check. Our benzene is a cyclic, our benzene contain alternating double bond and single bond, and interestingly this benzene has a flat planar geometry, and let us apply this rule. So this is a 2n 4n plus 2 is equal to pi electron. So let us count the number of pi electrons. Dear student, you might be known about a single bond is a consist of 2 electrons. So this is very important to understand. So this is a 1 pi bond. So this 1 pi bond counts the 2 electrons. So there are 3 pi bonds. So 1 2 3, so total 6 electron can be possible. So here 4n plus 2 is equal to 6 pi electron is there, and so if you solve this equation, so it will be 4n is equal to 6 minus 2, so n is equal to 4 by 4, that is n is equal to 1. So here the value of n is a 1, that is it is a complete number, then yes we can say that our benzene is a aromatic. Likewise dear student, you have to apply this formula to the any other compound that you want to decide whether this structure look like aromatic, but whether it is aromatic or not you can easily determine by using this Huckel's rule. So let us see one more example of this Huckel's rule. So structure which is very resembled to the benzene that fall in one category, that is called as a aniline. So this is the structure of aniline. So aniline containing alternating double bond and single bond. Yes, it contains whether the aniline is a flat structure, whether it is a planar, and let us apply the Hockel's rule for aniline. So you have to count the number of pi electrons. So it contains 2, 2, 2 and 2. So total 8 pi electron. So this is the 4n plus 2 pi. So 4n plus 2 is equal to 8. Okay, so 4n is equal to 8 minus 2, that is a 6. So 4n, n is equal to 6 by 4. So it will be not a complete number. So the number will not be the final. So you can solve it. So it is a 3 by 2. That is not a complete number. That comes in a decimal. So it is not a complete number. That's why this aniline is not a aromatic structure. So dear student, there is again a few very important example. So this contains the example of a furan. So this will be asked. So furan or pyrrole. So this will be asked for GPAT examination, that why pyrrole and furan, how they follows the Hockel's rule. So let us apply the rules to the pyrrole. So let us consider first is a furan. So dear student, this furan consists of one oxygen, and to this one oxygen there are two lone pair of electron. So these two pi electron, it means that there is a 2 electron, 2 electron, so total 4 electrons are there. So while applying this 4n plus 2 is equal to, so 4 pi electron. But if you calculate through this equation, so n will not be a complete number. So from that you can encounter that it is not a aromatic, but this furan is aromatic. So how this furan is aromatic? So you have to go into the orbital picture of a furan. So if you look from the sideways to the furan, so you will find, so this is a furan. So in that furan there are two lone pair of electron, and this lone pair of electron that fall in that orbital, and these orbital are perpendicular to each other, means there is a one lone pair of electron and here is a lone pair of electron. These lone pair of electron are perpendicular to the each other, their orbital is perpendicular to the each other, and the remaining p orbitals, these remaining p orbitals are look like this. So they get overlap over here like this. So that's why this double bond is represented. Okay, but interestingly, if we count these pi electrons only 2, then furan will not be the aromatic. But interestingly, furan is the aromatic. But how this furan becomes a aromatic? The reason is lying in between the geometry of this orbital, which contain lone pair of electron, and this lone pair of electron means it contain a two non-bonding electron, and these non-bonding electron, now these non-bonding electrons are parallel. So these electrons are parallel to this pi electron, and due to this reason there is a formation that non-bonding electrons becomes a part of this pi circulation. So they get a mixed they get circulated in the pi cloud, and that's why it shares the two electrons in this pi circulation, and that's why these furan contain total now 6 pi electrons. So if you solve this 4n plus 2 is equal to 6 pi electrons, then your answer will be 1, and hence this furan is aromatic in nature. My dear student, this remaining one lone pair of electron, it is a perpendicular, or it is a perpendicular to this pi orbital, and that's why it not take part in this pi circulation. Only one lone pair of electron is take part in the pi circulation. Dear student, I hope you enjoy this video, and one more thing is remaining, that is the structure of pyrrole. That structure of pyrrole is look like this, that is it contain a nitrogen having one hydrogen, and this nitrogen consists of this lone pair of electron, and again same like as the furan, this hydrogen is now at the place of this H. So nitrogen, so these are the orbital, and here it is a hydrogen, and this remaining one lone pair of electron on the nitrogen, it is same parallel like which is present in the furan, and that's why here is also, so this is 1 2, so this is one bond, this is one bond, and there is a two electron, and they get circulated inside, and that's why their value is again becoming pi is equal to the 6 electrons, and the value will be n is equal to 1. So this is all about the furan and pyrrole. Likewise, you can explain the remaining structure which contain a heteroatom, and you can easily identify whether the given structure is aromatic and non-aromatic. My dear student, this kind of examples are always asked in the GPAT examination, whether which of the following is aromatic or non-aromatic. So you have to explain that. So dear student, I hope you enjoy this video. If you like this video, then subscribe my channel, and in a next video we will explore the unit number 1 in more detail. So thank you for watching my video. Thank you very much.